In the back?
Yeah. Okay.
Yeah.
Good? All right. Okay. Hello, everybody. Thanks for coming to my talk. There are a lot of things going on, so I hope to make this a useful one that you chose to come to. I'm Matthew Miller, and I am the Fedora Cloud Architect, which means that Red Hat pays me to try and make the cloud experience in Fedora better. I'm also on the platform team at Red Hat as well, so I do a lot of stuff. But Fedora Cloud is my primary focus in Fedora. So the purpose of this talk is basically to talk about these three questions. What actually is cloud computing? Why should we care about it? And a little bit about what Fedora is doing with cloud computing. It would maybe be helpful to have a little bit of a sense of where people are on these questions. How many people feel like they have a good grasp on what cloud computing is? Okay, so I may be preaching to the choir a little bit here, but that'll be okay. So this is kind of a sort of aimed at not preaching to the choir and a little bit of cloud computing definition, but start with something a little bit about what the normal consumer view of what cloud is today. And there's a lovely video here.
Hewlett-Packard is known for their basic, affordable, no-frills computers, but that doesn't mean they can't keep up with the latest technology. In a press release yesterday...
Awesome. That is lovely. Try that again.
Hewlett-Packard is known for their basic, affordable, no-frills computers, but that doesn't mean they can't keep up with the latest technology. In a press release yesterday, HP said, quote, "We are excited to begin offering that cloud thing that everyone is talking about. We definitely have the cloud on our computers, and it is better than anyone else's cloud." Earlier today, I sat down with HP spokesman Gary Clinton, who said the company couldn't wait to show people, quote, how they do their cloud stuff.
We are absolutely thrilled that now people with computers or phones will now be able to back things up to the cloud. And yes, that's definitely something that people do, and they will be doing it.
HP is making their cloud technology the centerpiece of a major new print and television ad campaign.
HP is the company I've always relied on. So when I decided to get on my computer on the cloud, which is how we do it, naturally HP is the company I chose. HP's cloud is the perfect tool for emails, Facebooks, texting, and CD-ROMs because the cloud works. So it's simple and intuitive. I don't even waste your time explaining.
Clinton says it isn't surprising they're, quote, up on the cloud, considering they're on the cutting edge of all the latest tech trends. Now, are there any additional features?
Crowdsourcing is something we have. Crowdsourcing 2.0. We have social sharing. We have 4G, 5G, 6G, really all the G. We have all of it.
Despite all of their wide array of technology, HP says they're most excited about the cloud. They even let me take a peek at their design laboratory. They have some unique development techniques. So how much capacity will HP's cloud users have access to? 1,000. HP's cloud pays off. This tech trend, we'll be looking at body view, the popular new device that links with your iPhone to post all of your bodily functions right to Facebook.
All right. So having shown that, I need to apologize to HP. Do we have any HP people here? I'll apologize remotely. HP actually does have an OpenStack-based public cloud offering, and they participate in the Fedora Cloud SIG and give us free access to their cloud, and they're generally pretty awesome to us. So it's not quite fair to show this, but there it is. So I think in general, the normal person view of what the cloud is maybe remote storage. You've got the iCloud thing. Your stuff is backed up to the cloud. Web-based stuff, people might think of Gmail as being a cloud thing, or especially Google Docs and Microsoft's new Microsoft Office 365 or whatever thing. That's what the cloud is. And then also this marketing hype and more marketing and buzzwords, and it doesn't really mean anything. It's just everyone's putting the word cloud in everything. So that's definitely true that the word cloud is used in all of these things. But when we were talking about cloud computing, we actually mean something that is actually fairly specific, has a real meaning, and is different from all of that. So a lot of maybe 90% of what people hear about cloud isn't actually what we're talking about when we're talking about cloud computing, and especially as what we're talking about is cloud in Fedora and as a technical thing. So really, cloud computing is about computing as a utility, something that is not something that you have to build yourself, and you actually have it brought into your house or business just like you get water or electricity from somewhere else. And the things we're talking about here are basically memory, compute cycles, storage, software, all those things delivered to you as a service. And one of the things that's important about this is that this model of utility computing doesn't necessarily mean that you are buying it from a remote public cloud provider like Amazon or something like that. You can also use these same things internally, especially in large organizations, although smaller companies could too, but especially in medium, large, having your own cloud is an interesting way to go as well. So I'll talk a little bit about that. One of the other things that's kind of a big misconception or a thing is about whether this cloud utility computing thing is something new. Is it a fad, or is it just like we're talking about timeshare all over again? So everything's running on the mainframe, everybody connects to it. And I think that there's actually a fundamental difference this time around. Obviously, they're still in the same pendulum or spiral kind of approach where we go from thin clients to remote things, but there's a big difference. The timeshare in early times was sort of based on the fact there are only 15 computers in the world, so we need to make sure we get everybody in line to use that, and this is how you connect to it, and so we share it for that reason. Here we have a different situation where computing is everywhere. We have ubiquitous computing, basically, and so this is a good way to access that. And so it's a different picture than before. So there's a different thing that's going on than just timeshare. So get to some specific definitions of what cloud is. NIST, the National Institute of Standards and Technology, has a government definition of what cloud is, and as government documents go, it's pretty good. I've read, they've got some pretty geeky papers about a lot of different things, and this one is rather short. It's basically 3 pages of definition prefixed with like 20 pages of how a definition is defined and what a definition means and those kind of things. But the actual definition is pretty good. It says that there are basically these 5 characteristics that make something cloud. The first one is on-demand self-service. So you can get access to resources. Spot?
Make sure the streaming is going. We good?
We're good. You can get access to the resources you need, basically programmatically. You don't need to call somebody up, have them provision it, wait for them to provision it. You get your request approved. You basically ask for it and get it automatically. Broad network access, which basically means you access it via standards. It's something that's not a little proprietary system that's locked into you must buy this device and connect in this way. You access it over the internet from any operating system and any device. They have resource pooling as a fundamental thing. I don't know. I would argue this is really an enabling thing, not necessarily part of the definition, but basically you have dynamic virtual resources that are shared, and the important part about that is the next point. It gives you this appearance that everything is infinite. So basically you don't have, I got this limited resources that need to be divided up this way, but rather if I want to scale to 1,000 machines, I know I can do that, and someone behind the scenes is making those resources actually available and planning it so that will happen. And the final characteristic is measured service, which basically means everything is monitored. Usually it means that you're paying per hour or per minute for what you're getting, which is a little bit scary sometimes. But actually, if you use that to your benefit, it can make things be a lot cheaper and cost-effective and more efficient overall and better for the world, because you don't have a server that's sitting there and you don't really know what capacity is being used, what it's used for, and that kind of thing. As a sysadmin for large universities where I've worked for, we always know that this is a good thing, but never have time to put monitoring into place. So that's always been, I spent a lot of my career trying to retrofit monitoring on top of systems that were designed without that as part of the basic thought. So this is part of a trend in general computing and IT is that monitoring is actually really important. And so one of the nice things about cloud is that that measurement is built into the way things are done. So that's good. So anyways, this is the official US government definition. It's pretty good. There's another definition. Some of the people who are working in cloud think it's a little bit unwieldy. So this is the awesome definition. And so that gives a little acronym that's fairly easy to remember. It has a lot of the same characteristics: on-demand self-service, scalability, and that it's measurable. And one of the things that makes this definition simpler is that it kind of leaves out and just takes for granted that, yes, you can access all this through an API, and that's sort of the same as the broad network access in the other definition. So yeah, you often hear about things being talked about as awesome. Cloud is awesome. And that's what the reference is there. The other important thing about cloud, there's, you often hear about these AASs, the different as-a-service things. So this is also from the NIST definition, but also pretty widely used. Different ways in which the cloud services are delivered. So infrastructure as a service basically means you get a VM. Either you can choose from a list of operating systems, or you can upload yours there. So Fedora has a Fedora 19 cloud image. And so if you have an IaaS provider, you'd be able to basically get Fedora in the cloud. The next level of things is platform as a service, and generally that means that you have somebody, it's like with the IaaS, you basically have to be your own sysadmin. You have somebody else being the machine room operator, which is nice if you're a sysadmin. If you're at a large organization where you have a distinction between operators and admins, it's nice to be on the software side, I think, although some people like to be just messing with the hardware and don't want to mess with it. There's a distinction there. So IaaS puts you onto the sysadmin side. Somebody else deals with the actual underlying systems. Platform as a service puts you on the side where the sysadmins are also already taken care of. So you'll have your Django stack, your Ruby on Rails, or some sort of software stack that's basically there and taken care of for you, updated for security, and basically made available at that level. And then you can work at you're developing your actual application on top of that. So this is nice if you're a software company that wants to worry about an application that doesn't want to worry about the actual infrastructure underneath that application. And then software as a service is much more like the consumer level thing that people are more familiar with. This is basically you pay for access to some application that you usually get over the web. And this is also, in addition to the big things that are obvious from a consumer point of view, this is pretty big in the enterprise where people are, instead of having their own PeopleSoft installation or their own customer relationship management software, they actually pay for access to a service where somebody else takes care of it. Then we also have everything as a service, XaaS, and then so you often hear about storage as a service, networking as a service, security as a service. I don't even know what that means, but that's another thing. Some of the government documentation talks about email as a service, which again, that's Gmail, but somebody else contracting for these things. And then the final part of the definition is where your cloud stuff lives. So the first thing, actually I maybe have these out of order here, but the first thing here is private cloud, which basically means you are running infrastructure for this in your organization. You're paying people in your own organization to run server room like they always have. But instead of being a traditional IT organization where you have people make requests, hopefully through tickets, or maybe they walk in or on the phone, they make a request for something, and then you have to allocate your time for your people to make those resources available. You instead basically make the cloud resources available, make that API available to other groups in your company, and then maybe your IT organization can be more efficient and work on actual interesting things rather than setting up servers over and over and over again. The other one here is public cloud, which is Amazon, Rackspace, basically big companies that will sell you access to their cloud, and this is very popular as well. The next thing is community cloud, which is basically a mix in some ways between the things, which is where you have several organizations that go together to build a cloud system that's not necessarily for the public, but it's not one organization. A good example of this would be Massachusetts Open Cloud Initiative, which is the idea that Massachusetts, a bunch of schools and government got together to build a gigantic data center in Western Massachusetts. And the way people will get access to those systems there basically is through a cloud API for the system. So that's a community cloud. It's not open to the public, but just to the people who are supporters of this initiative. And they'll be able to share the resources there. And the final one is a hybrid cloud, which basically means that you have something which is, probably have something like a private cloud, that when your private cloud reaches capacity, it scales out to a public cloud, so that you, even if you have limited resources in your real organization, you can still pretend you have this infinity, and you have infinity is backed up by a much larger organization, which you can't really give that proper illusion of infinity. Okay, so that's basically the definition of what cloud computing actually is, which hopefully, if you're wondering if this is something really important, hopefully actually knowing what the definition is and what we're talking about makes it a little more clear than just the marketing buzzword, where it's pretty easy to just dismiss that HP video there about cloud, it's in your computer. But here when we talk about these actual things that cloud computing represents, it seems like it's a little, you can see that it's actually something that people might want. And so I have got a few numbers here that I was digging through to try and find some research on what are people actually doing this, or are people just talking about doing this? And this is from my Gartner report. I actually went and looked at a lot of different numbers. I thought that this was the most useful, but some other reports have pretty similar things. This is billions of dollars being spent on cloud things right now and projected over the next few years. So that's pretty big when we're talking about something like $60 billion a year overall. It's not maybe the hugest market in the world, but prospective operating systems are, we're in the same ballpark as selling operating systems overall, and people take that very seriously. It was kind of hard to find some of these numbers because of the marketing buzzwords, because some of the reports basically ask people, what do you think you're spending on cloud? And they come back with some pretty outrageous and vague numbers. But these are, I think, are backed up with some pretty good science behind it. So I thought those were useful. One of the other interesting things I found was a Cisco report on small and medium businesses, where people are spending about 30% of their IT budgets on cloud services. Half the small and medium businesses, that's up to 250 employees. And I thought this is kind of something that might be an interesting target for Fedora, where it's not necessarily enterprise scale things, but people may be more interested in exploring their more agile options. And IBM ITC report said that 3 in 10 mid-sized firms are adopting public cloud, and that's just public cloud. So other firms may be interested in private cloud and other cloud options as well. So there's definitely some interest in that area there. And then the other place where cloud is very important is startup companies, where really the question isn't, is cloud what people are using? It's what cloud stuff should I use for my startup? Because this is, you would be crazy to have a startup company today and build a data center. It would just be a ridiculous waste of your resources. And if somebody's telling you to do that, you're getting terrible advice and listen to somebody else instead. So this was a survey that Manchester Business School did. It was sponsored by Rackspace, who is a cloud provider, so it has a little bit of bias probably, but is a very positive pro-cloud study here, and 20% of startups. And this is important to note, this is not just tech startups, this is all startups of any kind of new business. 83% of them said that having cloud made it easier, and 20% said they wouldn't have been able to do it at all otherwise. I imagine those 20% are all tech companies, but so that it's pretty big in that area, and this especially is somewhere that we should be getting Fedora in on the ground floor, because moving quickly is what startups are doing, and that's what we're doing. It seems like a nice match. Another important thing, when we're talking about Fedora and the cloud is running Linux. In Amazon EC2, Linux is twice as popular as Windows. And another interesting thing from this report that I thought was kind of cool, the more powerful the system is, the more likely it is to be running Linux. This isn't really a surprise. High-performance computing is the same way across the board, but Linux is really what people think of as the serious option for cloud computing. This is another place where it's hard to get numbers because people don't like to let out their secret sauce there. And one of the biggest reports is the number of AMIs, the number of different machines available in the cloud. And that is highly misleading because Linux distribution other than Fedora tends to put out hundreds and hundreds of AMIs that get uploaded. So your options there are, if you look at what number of machines are available, is overwhelmingly a different Linux operating system, but that isn't really representative of what people are actually running. That said, Fedora is a kind of sadly small niche right now, and so we need to do some things to make that better. And that's what we're kind of working on in the cloud SIG. So I do want to talk a little bit about what we are doing in Fedora in the cloud right now, and kind of in these 4 different areas. Fedora running in the cloud, Fedora basically powering the cloud, how we are using the cloud in Fedora as a project, and also a little bit about Fedora as a cloud endpoint. And I'm going to go through this kind of quickly, I guess. So the first thing is the Fedora cloud image, and that's what you get if you go to cloud.fedoraproject.org. And basically, it is a spin of Fedora pre-installed that you can start up. It's basically a minimal install, the minimal at core, minus a few things, plus a few things. The big thing that we add is cloud init, which is basically a provisioning system, so that when you start up your image in the cloud, you can run commands on it. It puts your SSH keys into place, and you can have it install packages and get your system provisioned. And we had a couple other useful things like rsync that we put onto the image because it seemed like it would be useful to be able to rsync things onto your image right away without having to go through an extra step there. And we're going to refine that further in the future. I will note that we've done a good job. This is smaller on disk than all the other Linux cloud distributions that people tend to use. So if you want lightweight, we're very good for that. And so we have easily available, easily available a button. Yeah, it's not even my computer, man. A button so you can launch in EC2. You can go to the cloud.fedoraproject.org page and click a button and have the VM up and running in 30 seconds. Assuming you already have an EC2 account, it will be a little longer if you don't have an account already. And we also have downloadable QCOW and RAW images, which you can download and fire up in OpenStack or Eucalyptus or one of our other cloud, private cloud software we have. For the Fedora 20 release, one of the things we're doing is anybody here familiar with Vagrant? Okay. So this is something we've been missing in Fedora. Vagrant is a popular tool basically for developers to use cloud images that come in a standard way with basic provisioning tools on them. And you use this base box and you modify it to put your application on it and use that in the cloud. It's quite popular. We haven't had that in Fedora because having Chef available is one of the basic requirements. And we've had some work to get Chef into Fedora. We're finally going to have that for Fedora 20, and then we'll probably have Vagrant boxes. I don't know if those are going to be official downloads or if they're going to be on my Fedora people page, but we will try to have Fedora. This is a Fedora 20 feature, so we're working on that. Another big thing is more visibility. Right now, if you don't know that cloud.fedoraproject.org URL, you really have to dig on the Fedora website to find out that we have any cloud things anywhere. So for Fedora 20, we have a accepted feature to make the cloud image as visible and prominent as the desktop image. So when you go to fedoraproject.org, you'll see the cloud spin available there, and there'll be direct links to it. And that, I think, will, having it there really help people who are interested. But yeah.
By cloud images, do you mean just EC2 AMIs or other?
Right. So this is again launch an EC2 AMI and a downloadable QCOW images. So this is a Fedora 19 feature. We actually are producing these QCOW images as part of the release process. So they come out with everything else, not as an afterthought, and they're actually on the mirror networks. Which ironically makes it hard for me to give you good statistics about how popular they are, but they're actually mirrored all over the world, so there is a cloud image that is easily downloadable from wherever you are very quickly. And right now it's EC2 because EC2 is the only major cloud provider that makes it easy for us to actually make an official AMI. The HP cloud uses our official AMI with some minor tweaks. Some of the other ones, like Rackspace, basically do their own thing because they need the AMI, or their equivalent, their image to be customized in some very Rackspace-specific ways. which we're trying to work with them to minimize those differences, because it's kind of, the more identical it is, the more ideal it is. But they don't have a way to upload your own images. As soon as they have a way for us to provide our own images ourselves, we will do that. Yeah.
There was a desire to make these images usable by data center virtualization users like Web Manager, or just put the existing QCOPs and raw images.
Yeah, so this is an interesting project for somebody. If you want to boot this image and just use it in Vert Manager without having a cloud infrastructure, this image actually works just fine that way, except for, first of all, Cloud Init will not find a metadata service unless you carefully provisioned it yourself, and then which will be annoying because it takes a minute to time out, and then you will not be able to log in because there's no way to provide credentials. So you can actually provide, if you know what you're doing, provide that metadata to Cloud Init through like a floppy image you provide to it, or
or you could use GuestFS or something to edit the image.
Right. So
you can work with your DNS infrastructure and host your own metadata.
Right. So that's actually on my laptop. I have my own metadata service running because it runs on the link local, the well-known link local IP address.
It will also look up a fairly well-known DNS name.
Okay. Does it?
Instance data dot.
Okay. Cool. So there are ways to do that. But the cool project would be to integrate something into Vert Manager or libvirt where it actually has a metadata service that's just right there. So if anybody wants to hack on that, that would be awesome.
Yeah, you might want to send an email with what's the requirements.
Okay. Yeah, I think there actually might be a bug with some of the requirements there, but
there are a couple of interns who are looking for some requirements.
Okay. Yeah.
So I would definitely.
Okay. Yeah. And I think the libvirt people are interested in that as well. They just don't have the time to do it because there are a lot of requirements. Yeah. So, and that's really handy if you want to just develop things and then you work at that level, and then you have an image that you hacked up that you can then send to a cloud somewhere. The other thing we have in Fedora, going back to the cloud in Fedora, we have various cloud service software that's available in Fedora. Infrastructure as a service, we have both OpenStack, which is obviously what a lot of Red Hat people are working on in the RDO project, and that's been pretty good in Fedora, and a lot of things like the Heat project and a lot of things that are being developed in OpenStack go into Fedora first, and kind of Fedora serves as a proving ground for that. So we have OpenStack available, also Eucalyptus, which is another cloud infrastructure provider that its main claim to fame is trying to follow Amazon API compatibility, which if you're going back and forth and doing a hybrid kind of model, that's pretty nice. And it also has a lot fewer moving parts than OpenStack, so it's somewhat simpler to deploy. I'm going to have to say, having done both of them.
There's also a cloud stack.
Right. So that's on my next slide. Let me get there in a second. So we also have OpenShift is a platform as a service thing that Red Hat makes, and so we have the open source version of that. There are some things that are kind of missing, which is the software stacks, the cartridges, which power your actual platform as a service are not available in Fedora right now because a lot of them depend on software collections, which is a technology that the base tools for are in Fedora, but the rest of it, the actual stacks, are not. That's something I want to work on, and my other talk is a little bit about how we can make that happen tomorrow. And we also have some software as a service things like OwnCloud, which basically lets you run your own Dropbox, which if you are concerned about privacy and somebody else out there looking at your data, this might be an interesting option for your organization. Have that. And a lot of places like this is a big deal at a big university that I used to work at, where people were using Dropbox like crazy in violation of all sorts of federal law that Dropbox was not able to make the privacy guarantees we need for student access. And so having an OwnCloud instance of our own in our own data center let us make those guarantees that we can't do with some of the public clouds. Although it is worth noting that a lot of the public clouds are now really interested in these government certifications, and if you don't have a good sysadmin and security staff by yourself, running it in the cloud actually may make it easier to be compliant. But going around, we've got those things. So yeah, this is the nudge slide. CloudStack is a Apache open source project to do an infrastructure as a service cloud. It is very popular. It is not yet in Fedora. Do we have CloudStack people in the room? There's a stalled feature for packaging CloudStack in Fedora, and that's kind of waiting for people to work on it. And another really cool open source infrastructure as a service platform is OpenNebula. And all these names get really easy to confuse because they're either open or cloud. This is the only one you can keep straight. But the cool thing about OpenNebula is that it actually all runs basically on one controller node, and the compute nodes are just bare metal systems that have libvirt and SSH access to it. So from my sysadmin, thank you. From my sysadmin background, I really like this a lot because there's no weird agents running in each node. There are not a lot of moving parts at all. Everything is one server that controls everything. And they say they scale up to thousands or tens of thousands of nodes with that method. And that also has a pretty cool feature of having cloud bursting to Amazon built into it, so you don't have to set up something special to make that happen. This is pretty neat. I know CentOS project is using this in their infrastructure, which is cool. It would be nice to have this package for Fedora, and again, somebody was working on this, but it got stalled out. And so if somebody would like to pick that up, that's another project that would be interesting. So additionally, Fedora ourselves as a project are using cloud. We have Fedora infrastructure has an OpenStack instance that we use for a lot of different things. Is somebody from the infrastructure team here going to talk a little bit about what we're doing with that? Do you have to?
I can't. I'm just a user of this cloud.
Okay. So some of the infrastructure stuff is starting to run in the cloud, the local cloud instance. I do a lot of my development work there. This is sort of the next thing. If I'm doing cloud testing stuff, it's nice to have that available in Fedora. Some of the things I have an intern working on when I needed a system for him to work on, we just spun a system up in our local cloud, so it's nice to see those benefits that I'm talking about actually available to us. And so if you have a project where you need some resources, we can talk about that kind of thing too with our infrastructure team. They're pretty good about making those available when needed. We also have a shared EC2 account that Fedora uses for a lot of things, as we use a lot of testing there. And we're going to actually be doing automated testing of the cloud image in EC2 once all the bits for that get wired out as well. So we'll images come out of the build system. They automatically, after they come out of the build system, get uploaded to both the download site and to EC2. And the message gets fired off, and then the QA team will be able to pick up that message, fire up an instance, run their tests on it, and give a report on this image was good or this image was bad. This is kind of basic stuff, but good that we're getting ourselves around to doing the basic stuff at some point eventually. And so the other interesting thing is Fedora as a desktop and as a cloud endpoint. So especially from going way back to the consumer view of the cloud kind of things, the GNOME desktop has a lot of things like where you can sign into your online accounts as part of your login, which kind of makes it on par with the way iOS and a lot of the Android kind of works. So we're kind of the desktop is going the same way, but also the developer desktop is an interesting place for some more cloud features. So for example, having OpenShift, the platform as a service, integrated with those automated login. This hasn't happened yet, but it's kind of in the works, where you can log into your OpenShift online as well, and making it easy to do your development and push things because you have your authentication credentials built into the desktop. So there's some other things there, and I don't have a lot on the slide, but that's another interesting area for Fedora as cloud. So overall, cloud is not just a marketing buzzword; it is actually a real thing. There's real cloud computing going on. In fact, it's a fairly big thing. A lot of people are using it, and it is a future trend where I think this is the direction of IT in general. We are doing some great cloud stuff in Fedora. We're going to do more, even greater cloud stuff, and there's a lot of places where people's help is wanted. This is the Fedora Cloud SIG. This is our very lovely Fedora Cloud logo. Hopefully you'll be seeing the Fedora Cloud logo more often now that we are supposed to be on par with the desktop and more visible. And there's the Fedora Cloud Sig wiki URL. And joining the Cloud Sig is basically signing up to the mailing list and starting posting. There's no super formal process, but please do that.
There's also hash Fedora Cloud IRC.
Oh yes, hash Fedora Cloud IRC, and I'm usually there all the time, although I sometimes take a while to respond to things. But there are other people there too. And there, that's it.
Yay.
So we have a few more minutes. Anything people want to talk about? Questions? Suggestions?
That's what we're trying to talk. Volunteer.
I'm checking on IRC too.
I work for a small startup, and kind of in the startup scene, you know, it's not in a coming trend. It's a 2 or 3 years ago trend, you know.
Yeah.
I work for Animoto, which is kind of the poster child of cloud computing, because one time we had 1 million users sign up to make videos, which had spin up 4,000 instances on Amazon. And, you know, it's like, if you have like 50 computers or 100 computers, you're just hitting the luck.
Yeah, and if you have suddenly 1 million users because you were suddenly popular, and then later people wanted something else, if you would have provisioned a data center for 1 million users, and then after that wave was gone, you would be in trouble. So that's one of the, you can scale up and down again, which is one of the nice things. So you end up.
And I have to say, like, people like think about like cost savings and stuff in the cloud, but that's a red herring. It's all about the flexibility. That you don't have to think about, you know, what are my computers. You don't have to like keep a spreadsheet of MAC addresses, you know, things like that. Everything's an API. So like literally, Amazon's entire data center is an API.
Yeah.
And there's a thing called Gervon's paradox, where when you make something easier to use, people use more of it. You know, people use more cars, they use more electricity, they use all that. So when you move your computers to cloud computers, like suddenly you're launching thousands of them because it's like, oh, we could use this for test, for QA, for, you know, a development environment. And so like we have these environments where we spin up 30 servers at a time. Like, okay, this is the entire Animoto environment. And people can, you know, try it out and make little changes and then shut it down when they're done.
Yeah, just ask Netflix.
Netflix says they're saving money. Yeah.
Amazon, when you sign up for their cloud storage stuff, you're signing up for all these accounts. The only one I really understand somewhat is S3, but there's a whole bunch of other things. Is there any way you could kind of like just provide like a brief description of some of the more popular parts of the Amazon?
There sure are a lot of parts.
Well, the two big ones are S3, which is just file storage, and there's EC2, which is give me a box and rent it per hour, and I shut it down. And you know, once it's booted up, it's a regular box running Linux or Windows or whatever you want it to run. And you can SSH into it and install software out of it. And that's
Most of the other things are services on top of that. Like, for example, if you want to send email out of Amazon's cloud, you don't want to send it directly from your systems because it will automatically get thrown away as spam because
spammers use these.
Because if you are a spammer, this sounds great. Let me spin up a bunch of throwaway systems and send out spam. So basically, you can't send email directly out from EC2 and have it expect to get anywhere. So instead, they have an email sending service that you can use the API that you can subscribe to. So they have things like that. They have database stuff. They have load balancers and all those things. They're basic add-ons. But yeah, so S3 is the storage. EBS, which is basically volume-based storage backed by S3 storage, and EC2, which is the infrastructure as a service. Mm-hmm. Yeah.
For OpenShift specifically, I'm actually doing a presentation next, and I was wondering from you, since you have more Fedora Cloud experience, do you see there being an OpenShift spin or some other easy way to get people running with that?
I think that would be very interesting, especially if we can get a single node OpenShift set up rather than having multiple nodes.
We have a VM available now, but there's not a great installer,
Yeah, and it seems like having something where we could just a QCOW where you can just launch it. It would be pretty cool.
Totally. Yeah. Yeah.
Yeah. So yeah, one of the things we're talking about a little bit, there's sort of a question about what goes on the cloud image and how minimal is the point where we've made it so minimal that it's useless or not Fedora anymore. And some people want to have basically nothing there, and nothing there is too far, but where's the line exactly? So we might want to look at providing some different variants as well. Sort of okay, here is your super minimal. Here is something with more batteries included. Here's the Vagrant spin. Here's maybe one with OpenShift already provisioned on it. Those kinds of things might be a direction we could go. One of the things on the minimal question while I'm talking about it, one of the things I think that distinguishes what we want to do with Fedora minimal in cloud. So we want it to still be something that you can build. You can get from it up to the rest of Fedora. So it's not something where it's just a super minimal distribution that you compile everything else on top of. If you want that, Fedora probably not. You're not getting the benefits of it being part of Fedora anyways. So we want to have something where you start with this, and then you can yum install or whatever to get the rest of your environment there. You get the benefits of actually it being part of Fedora overall. Now I'm getting a big stop sign. So thank you everybody for coming and listening. And thank you for the computer. That was very helpful.
Yay, cloud.
Right, I did not start with the cloud.
Excellent. You got a great opportunity to plug your talk tomorrow. I am interested in other images.
We know if even this may get the Jeff or
I don't know.
yeah, because yesterday he wrote that one day it wasn't sure if he next session, so I guess I walked to.
Okay.
Yeah, thank you.
Yeah.
Yeah, he's the guy for the website.
Yeah.